Alrighty. This is Algebra 2, Lecture 921 and 22, OAS A2N12. The student will divide imaginary and complex numbers using the complex conjugate of the denominator to do so. Take 2. That means this is the second effort of trying to get this lecture correct. So here we go. If we're asked to find the complex conjugate, we need to define what that is, and I'll just show you what it is. Whenever we're given a binomial and we're asked to find the complex conjugate of that binomial, it's the complex number, real plus imaginary in each case. To find the complex conjugate, you just change the sign in between the two terms. So this is 2 minus 3i, negative 2 minus 3i. Notice I've just changed the sign in between. Change this sign to plus 3i. Change this sign to plus. You just change the sign in between the two terms. That gives you the complex conjugate of your complex number. Now what happens, what we're going to be using this for is if you multiply complex conjugates together using FOIL, things happens where all of our i's disappear. We won't have any I terms left, and that's what we're going to try to do in the bottom of our fractions. In the bottom of the fractions we're going to be dealing with, we will have i's, and we want to get rid of them. And I'm going to put another problem right here. Wait a minute. We'll try see how this works. Okay. Here we go. So what we're going to try to do is rewrite our complex fractions, where we're taking a complex number and dividing it by an imaginary number here. A number divided by an imaginary. Whenever we divide by a complex or an imaginary number, we want to rewrite this so that there are no i's values in the denominator. And the way we do that is to multiply the numerator and the denominator by the complex conjugate of the denominator. So we're going to find the denominator, take the complex conjugate of it, and multiply the top and bottom, the numerator and the denominator, and that will make the fraction such that it won't have an I in the bottom. It won't have an imaginary number in the bottom of the fraction. The denominator will be what we call rational. We're going to be rationalizing the denominator. And remember, finding the complex conjugate is just a matter of changing the sign in between if you have binomials. And if you have monomials, that's just one term, you just rewrite and change the sign. The complex conjugate of this will be negative 3i. The complex conjugate of this will be positive 3i. Okay, so here we go. We're going to try to use the complex conjugate to rationalize our denominator. What you do is you take the complex conjugate, multiply the top and bottom by it, simplify, and when you get done, you should not have an I in the bottom. So let's see if that happens. The complex conjugate of this is just positive I. I've got to multiply the top by the same thing. If you multiply the bottom of a fraction by something and multiply the top by the same thing, you've effectively multiplied this fraction by a fancy form of 1. And so I'm going to just rewrite this as 3i in the top. We can have i's in the top, in the numerator, we just don't want I imaginary values in the bottom. This is negative. I times I is I squared. Here a little flare goes off, and that's, I got to remember that I squared is negative 1. So this will be 3i in the top of the fraction in the numerator, and this is negative 1. Negative I squared is negative 1. Well, there's negative 1. The opposite of negative 1, so to speak, negative 1 is positive 1. It's 3i over 1, positive 1, and anything over 1 is itself. So this is just 3i. And on your worksheet, if you will take a look at that, you will see that this is problem number 1. Alrighty. On number 2 here, I think I've written problem number 3 from the worksheet. So I'll work this one, and we'll see if we come up with an answer that's one of our choices on number 3. Again, we're just going to multiply the top and bottom of our fraction by complex conjugates. And the bottom of the fraction should not have an I in it when we get done. That's what we're shooting for. If I look up here, I say, well, it's got an imaginary number in the denominator. I don't want that. So I'm going to multiply the top and bottom by the complex conjugate of the denominator. I'm going to multiply both by negative 10i. In the top, this is a binomial, so I'm going to have to distribute. This is going to be multiplied by both of these terms. So I'm rewriting negative 10i times 3 is 30i, negative. Negative 10i times 3 is negative 30i. Now I'm taking this negative 10i and multiplying it by negative 2i. That gives me positive 20 I squared. Negative 10 times negative 2 is positive 20. I times I is I squared. And we have to remember, I squared by definition is negative 1. So when I rewrite this, I'm going to call it 20 times negative 1. And in my head, I'm just going to call it negative 20. 10i times negative 10i is negative 100. That's 10 times negative 10. I times I is I squared. This is also negative 1. So now I'm just going to rewrite and see if I can simplify this any further. Negative 30i minus 20. The reason I'm calling that negative 20 is because this is positive 20 times negative 1. And then this is negative 100 times negative 1, which is positive 100. And we notice that our denominator no longer has an I in it. That's what we're shooting for. Now all we have to do is simplify our fraction, reduce our fraction, just like we did when we were in 6th grade or whenever it was we learned how to reduce fractions. We divide the top and bottom by the same number if we can. And I see every term here will divide by 10. So I'm going to divide everything by 10. And I should be looking at the answer if I haven't made any mistakes. So I'm dividing everything by 10. That gives me negative 3i minus 2. 100 divided by 10 is 10. And I'll check my answer sheet. And yay! Let me see if that is right. Let me see if I can find it. Negative 3i minus 2 over 10. Yay, that's correct. Traditionally, what I was doing on the last lecture, the reason this is the lecture part 2, take 2, is because I was writing all the answers in what's called standard form. I would break this into 2 fractions and then write it as a plus bi. But the answer key doesn't write the answers that way, so I'm redoing this lecture to be in line with the way the answer key works. Okay. So there we go. There's 2 examples. Here's the last type of problem you might see. I think this one coincides on your worksheet with number 7. It does. This is number 7 on the worksheet. And I'm just going to multiply. I see that I've got an I, an imaginary number, a complex number, in the denominator, and I don't want that. So my technique is to multiply the numerator and the denominator by the complex conjugate of the denominator. So I'm just going to multiply the top and bottom of this by 2 minus 3i. And I've got some foiling to do. I've got to foil, I've got to distribute. You can think of it as double distributing. I'm going to foil this and combine like terms, and I'll do the same thing down here. And in the bottom, when I get done, I should not have any i's if I don't make any mistakes. Should have no imaginary numbers. So here we go. I'm going to take this negative 2 and distribute it throughout this quantity. Remember that the minus sign travels with it, so to speak. And this will give me negative 2 times 2 is negative 4. Negative 2 times negative 3i is positive 6i. Then I'm going to take this positive 5i and distribute it. And this will give me 5i times 2 is positive 10i. and 5i times negative 3i is negative 15 I squared. And again, whenever I see I squared, a little flare goes off in my head, because when I rewrite this, this is going to be negative 15 times negative 1. I'm going to call it positive 15. Okay? In the bottom, I'm going to do the exact same thing I did in the top, and I just foiled, so to speak, the numerator. Now I'm going to foil the denominator. I'm going to take this 2, and I'm going to distribute it throughout this quantity. And rewrite. It's 2 times 2 is 4. 2 times negative 3i is negative 6i. I'm going to take this positive 3i and do the exact same thing. I'm going to take positive 3i and distribute it throughout this quantity. And this will give me positive 6i, negative 9i squared. And again, I squared is negative 1, so that sets off a little flare. This is going to be negative 9 times negative 1. When I rewrite it, I'm going to call that positive 9. But here we go. I'm going to simplify the top. I've got negative 4 plus 15. There's negative 15 times negative 1. So I'm thinking this is positive 15 right here. This here. So 15 minus 4 is 11. And I've got these like terms I can combine. That's 16i, 11 plus 16i. And in the bottom of my fraction, the denominator, I've got 4 plus 9. This is negative 9 times negative 1. So that's 13. That's combining these like terms. And 6i minus 6i, those are different signs, so I'm going to subtract and get a 0. So I wind up with 11 plus 16i over 13. It doesn't look like they'll reduce. These two are both prime, so I can't reduce it any further. And hopefully that's one of my choices. So I'm going to look and see if that is one of my choices. Yes, this is, as I said, this is number 7, the original problem. And the choice B is 11 plus 16i over 13. So yay! I hope that gives you some idea of what we're doing and the form that we're leaving it in more than anything. You multiply the numerator and the denominator of any complex fraction that involves complex numbers, where the denominator is a complex number or a pure imaginary number. Just multiply the top and bottom of the fraction, the numerator and the denominator, by the complex conjugate of the denominator. And what happens is the denominator is no longer, the bottom of the fraction no longer has an imaginary component. It becomes real, it becomes rational. And so that's how we do it. We multiply the top and bottom of this fraction by the complex conjugate of the denominator. Multiplying by a fancy form of 1, anything divided by itself is 1, so I don't change the value of it, but I do change the way it looks. This no longer has an imaginary component in the bottom of the fraction, which is what we're shooting for. I hope that makes sense.